Hopefully you'll find this helpful. I don't know that I'll be able to cover every single thing, but I thought I could cover a couple of things that might be beneficial for you as far as completing this trig stuff. One of the things that they ask you to do is to convert degrees to radians and radians to degrees. Well, first you got to kind of understand that 180 degrees is pi radians, and all the radians are measured with a pi unit. So what you're doing is multiplying something by 1. You're either multiplying it by pi over 180, or you're multiplying it by 180 over pi, because those are equal, and it's just like multiplying by 1. So for instance, if we have negative 3 pi over 5, and we want to find that out what that is in degrees, we're going to multiply that by 1. We're just going to call our 1 whatever it would be with the pi in the denominator, so the pi's cancel. So when the pi's cancel, we have pi over pi cancel out, and then let's see, 5 goes into 180 36 times, so 5 goes into 5 once. 5 goes into 180 36 times, so all we're left with is negative 3 times 36, and 3 times 36 is 108, so it's negative 108 degrees. Not 180, oops, negative 108 degrees. So negative 3 pi over 5 is the same thing as negative 108 degrees. So it's really not that complicated to do, and we can do it in the other direction as well. Let me kind of just draw a line here. Let's say we wanted to convert, let me grab my pencil back, convert, I don't know, how about something like 280 degrees? And we want to convert that to radians. We can do that. What we're going to do is multiply it by 1. We're just going to call our 1 something very wise that puts a pi back into it. And we're going to multiply it by 1 by calling it pi over 180. And then we can reduce. So let's see, so that gives us 28 pi over 18, because those are both divisible by 10. And then we're just going to reduce that. Let's say 4 goes into, nope, not 4. How about 2 goes into both of those? So that 2 would be 14 pi. And 2 goes into 18 9 times. And 14 is not divisible by 3. So 14 pi over 9 is the same as 280 degrees. So that's what's going to happen when you're converting back and forth. So that's not too terrible. What else do we need to do here? We could do problems that deal with, there's so much to do, the unit circle. Let's talk about how the unit circle is created. I don't memorize the unit circle. What I'm going to do is create the unit circle, and I really don't have it memorized. I just know how I'm going to divide it up. So my unit circle is just a circle that goes like this. And first I'm going to do it in the 45, 45, 90. What's the word that I'm trying to think of? 45, 45, 90. That's what I'm going to do. Oops. So that's 45. Whoops. That's 45. That's 45. And that's 45. So this is a 45, 45, 90. Now I want to count this in radians, because that's how the unit circle is not mostly done, but often done, is 180 in radians. 180 is not there. So this is going to be 0 degrees, and we know that this is 180 degrees. A straight line is 180 degrees. And you measure from 0 in this direction. So it's going to be 0, 45, 90, and then the next one and the next one and all the way around, and we can keep going around. That's where those coterminal angles come from. But we're going to label the things that we know. That's 180, and we know that 180 is the same thing as the pi. Well, this one is half of that, so it's pi over 2. And here's how I look at it. I've got my pi. See, there's one section, there's 2 sections, 3 sections, 4 sections. I've got these pi sections divided into 4 pieces. So this is going to be pi over 4. This one is 2 pi over 4, which is a half. This one is 3 pi over 4, and 4 pi over 4, that's 1 pi. Then this one's going to be 5 pi over 4, and 6 pi over 4, but we could reduce that to 3 pi over 2, so we'd want to reduce it. And then 7 pi over 4, and then 8 pi over 4, which would be reduced, of course, to 2 pi. So I didn't memorize those. I just can count 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. And I'm just counting in my counterclockwise way. So I've memorized where the degrees are on my unit circle for the 45, 45, 90. Let me show you how that works with the 30, 60, 90. This is, I don't know what I drew there. Let me fix that. That was 6 pi over 4. Oh, I drew a line through it because we reduced it. That's right. All right, so let me show you what that's going to look like with our 30, 60, 90. Oh, let's not do it like that. Let's use our little straight drawing tool because that's a mess. All right, our 30, 60, 90 one can be done very similarly to get our radian measures. We'll see if I can draw a circle on here that's halfway circular. That's kind of sort of egg-shaped circular. Oh, that looks so bad. All right, so we still have 0 degrees here. We still have pi here, or 180. And now we're going to divide it into our 30, 60, 90 divisions. And the 30, 60, 90 gives us 2. Each of the quadrants is dividing into 3, so we have 2 lines. And let's assume they're equal. They're not because my circle is so lopsided. And we know from 0 to pi, I've got 1 section, 2 sections, 3 sections, 4 sections, 5 sections, 6 sections. So my first one's going to be 1 pi over 6, then 2 pi over 6, and of course we would reduce that, then 3 pi over 6, and again reduce it, 4 pi over 6, and reduce it, 5 pi over 6, and then 6 pi over 6, which is just pi, 7 pi over 6, 8 pi over 6, and then of course we're going to reduce, and then 9 pi over 6, 10 pi over 6, 11 pi over 6, oops, that's 11 pi over 6, and then 12 pi over 6, or 2 pi. So we can go back and reduce these. This is pi over 3, this is pi over 2, which we knew that from before. This one's 2 pi over 3. And hopefully you're comfortable reducing 4 pi over 3. 9 pi over 6 reduces to 3 pi over 2. Let me just erase it because I don't think it'll fit. 3 pi over 2. And then 10 pi over 6 is the same as 5 pi over 3. We're almost done. 5 pi over 3, and then 11 pi over 6. That doesn't look like an 11. I can fix that. And that's where those degree measures or those radian measures come from on the unit circle. So they're not that hard. You don't have to memorize them. You can just know how to count to 12 or know how to count to 8. And then you can do that. So it's the 45, 45, 40, 45, 45, 91 is divided into 45, 45, 90s unit circle, right, is divided into 8ths, or each pi is divided into 4ths, and then the 30, 60, 90 is divided into 6ths, and just count 1/6 through 12/6. And that's how those are going to be done. So there's lots of different ways to use the unit circle, and it really is not that complicated. So I wish I could leave this up here. Could I do 2 of these on one screen? I don't think I can. Let's real quickly go through the triangle trig stuff. And just as a refresher, when you're dealing with the triangle, the triangle trig is all right angles. The hypotenuse is always across from the right angle. And then you have to determine which angle you're talking about. So if this is our theta, then this is the adjacent side, and this is the opposite side. It's the opposite of the theta. If you're talking about the triangle being like this, and this is the theta, then this is the adjacent side, and this is opposite of the theta. So you just have to remember that opposite is across from it and it's not one of the sides that make up the angle, and adjacent means next to. All right, so that's kind of how that works. So let's say, for instance, we had a triangle. Let me come up with a triangle that is really a triangle. Hold on a second, I've got some practice problems here. How about, what if I had a triangle? Like this, and I had 9, and I had 5, and I knew it was a right angle, and I didn't define the 6 triangle trig functions that related to this triangle. And let's say, oh, I guess I need to label a theta. Let's say this angle is theta. Well, the first thing I need to do is find the measure of the other side. So that's not too hard to do because we can use Pythagorean theorem to do so. So let me make some space right here. Just get rid of this. Oops, I've deleted my 9. Let me stick it back on there. 9. So we're going to have 81, which is c squared equals a squared plus b squared. I just kind of did that backwards. And then 81 minus 25 gives us 16. Wait, no it doesn't. 81 minus 25, 56. Sorry about that. Is 56 equals b squared. So the length of b is the square root of 56. That's fine. We can call that the square root of 56. Is there a perfect square in there? I think there is. 4 goes in it. So it would be square root of 56 is 4 times 14. So that would be 2 square roots of 14. So we're going to call this side 2 square roots of 14. And now what we want to do is find the sine, the cosine, the tangent, the secant, the cosecant, the cotangent to this triangle. And actually I'm going to move the triangle over a little bit so we can actually have some space to work. Alright, so let's do the sine of theta. Remember, the sine of theta is opposite over hypotenuse. Well, opposite of theta is 5 and the hypotenuse is 9. So our sine of that angle theta is 5/9. The cosine of theta is adjacent over hypotenuse, and that's going to be the adjacent side to theta is 2 square roots of 14, and the hypotenuse is 9. That's a square root of 14. That just looked really messy. Square root of 14. And then we can do the tangent of theta. Now remember, the tangent of theta is opposite over adjacent. And there's lots of ways to remember that. I'm going to show you how I remember it in just a second. So the opposite side of that is 5, and the adjacent side is 2 square roots of 14. Now here's the thing. You can't leave the square root in the denominator because, I don't know, you just can't, because that's one of the rules in math. And I have to be honest, it's one of those that I don't understand why, but you're not supposed to. So we're going to go ahead and rationalize that by squaring both sides, or squaring the top and the bottom by the square root of 14. Oops, I meant to pick the black color. So we end up with 5 square roots of 14 over 2 times 14 is 28. Okay, so that's the tangent of theta. Great. Now, let me make some more room for our secant and our cosecant and our cotangent. Alright, so first, before I do that, let me show you how I remember sine, cosine, tangent. I can remember that they go in that order, but here's how I do it. I think about, and this is just me, I know some people like the SOHCAHTOA, but I don't like that because I don't know how to spell that. I do this. Orange horses always have orange ankles. I remember that acronym. Orange horses always have orange ankles, and that helps me to remember opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. And I know it's sine, cosine, tangent. So that's just how I do it. You could also say, there was another one with ants. Or apples, or I don't remember it, but come up with an acronym that makes sense to you. Now, here's the two, cosecant and secant. And I gotta tell you, I always want cosecant to be the reciprocal of cosine, and it is not. It is the reciprocal of secant, of sine. And that's how I remember that sine and cosecant are reciprocals of each other. So CSC theta is just the reciprocal of sine, so it's just going to be 9/5. Okay, that 9 looks really messy, doesn't it? Let me fix that. Okay, so sine and cosecant are reciprocals, cosine and secant, and I really want, and I have a degree in math. I've been teaching for 100 years, and I want cosine and cosecant to be reciprocal, and they're not. And secant and cosine are reciprocals, so I'm going to flip this 2 square roots of 14, and then you have to rationalize, so we'd have to do a little more work to get this rationalized, so don't forget to do that for this one. And then tangent is the reciprocal of cotangent. I'm going to squeeze it in here, and we're going to do the reciprocal as 2 square roots of 14 over 5. So that gives us our sine, cosine, tangent, our cosecant, secant, and cotangent functions of theta. So that's a little bit of a very fast review on some triangle trig, and hopefully that's helpful to you to kind of pull it all together. There was a ton of information in this unit. I didn't get any questions, which concerned me a little bit. But I'm sure that you're working hard, and keep me posted if something comes up that you need help with, because I'm sure as you begin to study through this, or as you finish up your studies through it, that I can help you out with it. All right, I will see you soon. Shoot me a webmail or a message if you have any questions, and I will be glad to help out in any way that I can.